Now we are ready to do the problem. The polynomial has real coefficient. What does that tell you? For the coefficients to be real, all the roots had to be conjugate. That is, if this is a root, 2i, it says it is, right? Equals 0, so it's a root. Then you know negative 2i also was there. And what about 2 plus I? You know, 2 minus I also was a root. Okay, so now they want to add this. You know what to do to get that. F of 1 minus 1 is what we want to do, right? But what was the function? That would give me a plus b plus c plus d. But what was the function? Function was this. But, you know, they told me what the roots are, so I can rewrite this function as x minus 2i. And you know, there's conjugate, it's x plus 2i. And what about this? It was x minus 2 plus I. And there was x minus 2 minus I. Okay? Okay, now, shall we look closer? This is f of x, by the way. So I'm going to plug in 1. And then I will subtract 1. So let's plug in 1. I get 1 minus 2i times 1 plus 2i. And here I get 1 minus 2 minus I, so it's negative 1 plus minus. One minus 2 minus I, so it's negative 1 minus I, and 1 minus 2, negative becomes positive I. This is what we get. Okay, so now multiplying this is easy. This is you know, difference of square form, so it becomes 1 plus 4 for this guy, and this becomes 1 plus 1, which is 5 times 2. Which is 10. But then again, I have to subtract 1 all the way. So I have to subtract 1 from them. So the answer is 9. So the answer is D.